Kia ora Year 12. This is question 1D from the 2021 Algebra exam. We're asked to consider the following two curves, this one and this one, and to find the coordinates of each intersection point of the two curves. So these curves are a little bit different from what we've seen. Well, this one is anyway. Okay, so this is a hyperbola, and that won't mean much to you just yet, but at the end of this video I'm going to show you a graph of what this question looks like. Now there's nothing stopping you using your graphics calculator to draw those curves yourselves and get a feel for what you're going to do to find your answer. But this one here is x squared, it's got x squared and y squared in it, and this has got y and some stuff here. So I think the obvious first step to do here is to expand this out. Now there are two ways, at least two ways to do this question. The first way that I did it, and then one that I think more of you might have tried, which is a little bit more work. I'm going to go through both ways in this video. That's why I've done a separate video on it, and I'm going to go really, really slowly. Okay, so the first curve we've got is x squared is equal to y squared plus 1. And the second curve is y is equal to, right, so here we've got a difference of two squares, so it's x squared minus 1 minus 2. So we've got y is equal to x squared minus 3. And we have to find the coordinates of each intersection point of the two curves. So we want to know when is this true and when is this true. So if you just take a break before you dive into lots of messy stuff and have a look at it, you can see that here we've got an x squared and here we've got an x squared. What we don't like so much is that here we've got a y squared and here we've got a y. But we could make x squared the subject here and write y plus 3 is equal to x squared. Right, so now we've got y plus 3 is equal to x squared, and we've got y squared plus 1 is equal to x squared. And so the intersection point will be when this and this are the same, right? So one more time, we know that for this curve, x squared is equal to y squared plus 1. And to be on this curve, x squared has to be equal to y plus 3. So the intersection point is where this thing and this thing are matching up. So we need to have y squared plus 1 is equal to y plus 3. That's a simple quadratic, and that's going to give me my y values, and then I'll just have to figure out my x values. It's not going to be that hard. So y squared minus y, and I've got plus 1, take away 3, so minus 2 is equal to 0. Now that factorizes, no need to do anything complicated. That's going to be y times y, then I'm going to have minus 2 and plus 1. That means that y has to equal 2, or y has to equal negative 1. Now I'm going to go back now to either of those equations and find x. I did it using this one here, but it will work if you use this one here as well. So we know that y is equal to x squared minus 3. So we're solving 2 is equal to x squared minus 3, or negative 1 is equal to x squared minus 3. 5 is equal to x squared. So x is equal to either the square root of 5 or the negative of the square root of 5. So that's for the first case where we've got y is equal to 2. So the first two intersections are root 5, 2 and negative root 5, 2. And I'm going to do the same thing for this one here. So we've got negative 1 plus 3, so 2 is equal to x squared. X is equal to root 2 or negative root 2. So my two intersection points here are root 2, negative 1, and negative root 2, 1. So there are 4 points of intersection. Okay, the first, the second, the third, and the fourth. So that's one way to do it. Now I'm not going to show you the graph until I've done the other way. if you didn't notice that that would work and give you a pretty clear next step, then this is what I think some of you will have done, and you're going to end up getting a disguised quadratic. It's not that bad, and you'll see pretty quickly how they're going to come out to give us the same results. So I'm going to go all the way back to here, get rid of a whole lot of the mess. So we've got those two equations that we have to equate. We've got x squared is equal to y squared plus 1, and we've got y is equal to x squared minus 3. So if you're looking at that and you see the y squared here and the y here, your first step might have been to say, well, we can get y squared. So y squared is equal to this. Expanding that gives me a quartic, x to the power of 4 minus 6x squared plus 9, right? So some of you will have had a slower step in there, which is all good. What I'm going to do now is take that expression, right? So I've got this y squared thing here, and I'm going to take it and substitute it in to this equation that I'm marking with a star. So we get x squared is equal to x to the power of 4 minus 6x squared plus 9 plus 1. We're going to turn that into a disguised quadratic as follows. We've got 0 is equal to x to the power of 4 minus 7x squared plus 10. If you're watching this video, chances are you've done quite a few of these questions because they come up all the time in the level 2 algebra paper. So my next step will be to say, let u equal x squared, or whatever variable you want. And now we've got 0 is equal to u squared minus 7u plus 10. Now I just need to get rid of this mess from the other way of doing it. And you can see what we're going to do now is we're going to solve that quadratic for u. So 0 is equal to u minus 5 times u minus 2. U is equal to 5, or u is equal to 2. So here we're going to get the x values coming up first. So x squared is 5, or x is 2. X is equal to the square root of 5, or negative square root of 5, or root 2, or negative root 2. And what's y squared? Well, y is just x squared minus 3. So y is equal to 5 minus 3, which is 2. Y is equal to 2 minus 3, which is negative 1. So again, we want to write out those solutions nicely. And you can see that they come out to be exactly, of course, what we've got the other way. So I'm just going to leave them there, right? So you've got your two x values with one matching y value. Now, when you've got a question like this, it's always a good idea to go back to the original equations and just check that all four of those solutions really are solutions. Okay, I've got time to do that, so I think I am going to do that, even though I know that most of you are now going to turn off the video. But I can't stress enough, especially when you get to level 3 next year, how often we solve an equation where we're taking square roots or squaring, and we either get an extra solution coming in, or one of the solution, or the solution that looks like a solution isn't really a solution. Okay, so let's take these points and just check that they do work. So root 5 and 2. Well, here, let's see. The left-hand side, x squared gives me root 5 squared, which is 5. I can't use that pen, it's way too thick. I'm sorry if that's annoying anyone. And then the right-hand side is going to give me y squared, so 4 plus 1, which is 5, which is the left-hand side. Okay, and we can go on and we can do that for the other 3 points. And we should also check it in here as well. Yeah, that's, so this one here, we've got y is equal to x squared minus 3. So checking, for example, root 5 and 2, the left-hand side is simply 2, and the right-hand side is root 5 squared, so 5 take away 3, which is 2. So it works. Now the last thing I want to show you is the graph of these. The first thing to notice is that we know what the graph of this is going to look like. This is really easy. This is just a straight up parabola that's been translated down 3 units. But this thing here is something that you won't see until level 3 if you do an achievement standard called conics. Now that doesn't mean it was a bad question for this paper. It's a good algebra question. It's just that there's a lot more depth that we can go into on these things that are called hyperbolae. Okay, so this is what it looks like here. The grey one, or maybe the green one, depending on what you see. This one here is our y equals x squared minus 3. And the blue one is what we call a hyperbola, which has the relationship that x squared is equal to y squared plus 1. Now, the reason I said relationship and not function is that there are 2 values of y for most of the values of x, right? So that's how come we're getting our 4 intersection points. So you can see that there they are there. Okay, right, so that's all for now. I'll do the rest of the paper over the next few days or maybe next week. Let me know if there are any specific questions that you'd like me to video.